So whenever I tell people that I work for Apollo GraphQL, people generally have one of two reactions. They're either insanely excited because they're already bought in on GraphQL, or they're wondering what on earth GraphQL is, either because they haven't heard of it, or more often because they have heard of it because it's a tech buzzword, but they don't actually know what it is or what it does. And so for this talk, I want to go back to the beginning and start with a really, really basic question. What is a graph? For the majority of the population, when you say graph, they think of something like this, where data is being displayed visually on labeled vertical and horizontal axes. And those kind of graphs are cool, but the more relevant question is what a graph is in the context of GraphQL. When we talk about a graph in GraphQL, we're talking about a mathematical concept called graph theory, which also has been brought over into computer science. So the basic concept in computer science is that graphs are used to represent networks of communication, data organization, computational devices, the flow of communication, etc. Okay, y'all did not just come here to listen to me read you Wikipedia as you desperately fight to stay awake. So let's take a look at a couple of more concrete examples of graphs. The first concrete example of a graph representing data is email. In this diagram, there are circles that represent both the users and also the emails that those users send to each other. And the way that each of these relates to each other is represented by the lines which connect them. If you look closely, though, you'll notice that in this case, these aren't lines, they're arrows. That's because in the relationship between a sender and a recipient, the sender always sends to a recipient. There's always only one direction things can go. And unsurprisingly, this is called a directed graph. Another kind of graph you may be more familiar with is something like Facebook or LinkedIn. Each person has to agree to connect to the other person. And then once that connection is made, things can go either way between the two people. And this is called an undirected graph. And you can see that both kinds of graph have two general things in common. The nodes are individual pieces of data, which in both diagrams were represented as the circles, and then the edges, or the relationships between the pieces of data, which were represented by the arrows in the directed graph and by lines in the undirected graph. Now, particularly for those of you who have previously done a lot of work with core data or other relational databases, this may sound a little bit familiar. This sounds just like the entities and the relationships in a core database, and clearly there are some similarities. But does that mean that a relational database is a kind of graph? Well, not quite. There's some important differences. The biggest of which is the focus of how data is structured lied. In a relational database, the focus is on the nodes and the relationships are somewhat secondary. And this is something that core data actually abstracts away for you. But you can see if you compare the entities, which in this little sample are a launch, a mission, a rocket, and a user, with the underlying SQLite database created by core data. You can see those four entities get their own tables in the database, but there's a fourth table before you start getting to the Z underscore metadata tables, the passengers table. And if you look back at the core data diagram to try and find out where passengers came from, you can see that it's one of the sides of the only many-to-many relationship in this model. While core data itself is capable of glossing this over, relational databases are focused only on single relationships, not many-to-many relationships, and certainly not traversing relationships over and over again. This is instead what graphs are focused on. How is the data that you have related to other data you already have? And how can you traverse that data to find the data that you want? For example, if you have a social graph where each person has information about various relationship edges to person nodes, you can do things like request the user's, father's, best friend's, oldest child's middle name. How do you find out about these relationships? What are the nodes that are available to you and the edges you can follow in the graph? The answer is, big surprise, GraphQL. And the QL there, similar to SQL, stands for query language. It's a way to ask the graph about what it's got. So now that you know what GraphQL is, you might be wondering, how do I actually use this thing? How do I find out what to query and how to do it? I'm going to be giving some examples using Apollo's sample server, which is the result of our full stack tutorial and which gives information about various SpaceX launches and allows you to pretend to book a trip on one of them. After the last few months, I'm sure that sounds like a really attractive vacation to a lot more people than it did before. Anyway, the first thing to understand is how GraphQL tells you what you can ask for, and that is through the schema. The schema is a definition of every type of node available to you and what properties it has, including properties that are essentially other objects, meaning that there's an edge connection between them, as well as what operations are possible. The basic thing the schema does is define what it's possible to ask for, written as a sort of contract. And the schema is often written in a language called schema definition language, which is pretty similar to TypeScript, which is a thin typing layer on top of JavaScript. So here's part of the schema for our sample server, which, as I said, lets you learn about SpaceX launches and pretend to book a ride on one. And one thing you'll notice real quickly is that this part of the schema is all about defining types. And this is where Swift and Kotlin developers get really excited because we really love the ability to have type safety. There's no more question of what type a particular item is going to be when it comes back from the server because there's a defined type it should be in a contract. So if that's going to change, then the schema would also need to change. Now, you don't want to go around creating types out of absolutely nothing. So you'll notice that there are a few common types that not coincidentally line up pretty well with what you can get for JSON. And these are called scalar types, and they're basically the base level building blocks of the type system. You can build types out of these scalars, then out of those types, then out of those types, and you can have a fairly comprehensive type system pretty quickly. Now, one thing I do want to warn about is how optionals work with GraphQL, which I am going to do in the form of a pop quiz. Sorry if this gives you flashbacks to high school. The question that I'm asking is the following type optional? And the type is string with no annotations. And of course, the answer is that it depends on whether you're working with Swift or Kotlin or with schema definition language directly. Now, you may think that I'm trolling you because it depends is a horrendously senior developer answer, but the fact of it is that there's a difference between Swift and Kotlin and GraphQL when it comes to optionals. In Swift or Kotlin, if you want something to be non-optional, you just write the type name with no annotations. For GraphQL query language, the way you annotate something as non-optional is to give it an exclamation point. And I know that many Swift and Kotlin developers are slightly horrified by this since you've been well trained to run screaming from the exclamation point as particularly in Swift, it's a force unwrap. But the reason for this is that in GraphQL, types are designed to be nullable by default. So you need a different kind of annotation to indicate that a particular item is not nullable. So you're going to have to get used to that exclamation point not being wrong. Now, if you do want something to be optional in Swift, in Kotlin, we have our good old trusty question mark indicating, well, we're not sure if it's there or not. And since things in GraphQL are optional by default, that means optionals in GraphQL have no annotations whatsoever. And this is definitely annoying to deal with this, but at a certain point, if you work with it for a while and or have a big enough glass of wine, it basically starts to make sense. Now, once your types are defined in the schema, it's time to define what operations you can actually do with them. This is basically defining where you can start getting into the graph. And there are three types of operation in GraphQL. A query allows you to say, please give me this data. In the case of our sample server, you can get information about launches in general, a specific launch, the current user, and how many trips have been booked in total. A query is by far the most common type of operation, to the point that the words query and operation are often used totally interchangeably, even though one is more of a subset of the other. This is even true in Apollo's docs, which we're working on fixing, but it is a very common thing throughout the GraphQL ecosystem, so it's really worth being aware of. The next most common kind of operation is a mutation, which allows you to specify how you would like data to be changed and then gives you back the result of that change. In this case, you can book or cancel a trip and then receive a typed response in return that you can then get whatever information you want from that. You can get login and get an auth token as a string, or you can upload a profile image and get information about the current user. And these are all one-shot deals. You ask the server to make the change, it makes the change, and then gives you back what you asked for. If you want something that updates more often, you want the third type of operation, the subscription, which allows you to be proactively updated when data changes on the server. Under the hood, this is generally done through WebSockets, though it doesn't necessarily have to be. Speaking of doesn't necessarily have to be, subscriptions are a cool trick, but you need to be careful because not every server provides support for them, and you can really get yourself into trouble if you are not careful, like these kids. So now that you know from the schema how things are related to each other and what you can ask your server for, it's time to actually learn how to ask for it. We're going to start with something that's actually baked into almost every GraphQL server, and that's a tool called graphical or GraphIQL. Nobody really seems to be able to agree. For the purposes of what we're doing today, let's call it graphical. One small piece of background to understand is that instead of having multiple endpoints the way REST does, there's only one URL for GraphQL, since the way that you ask for things is defined quite differently. I'll be walking you through how here in a bit, but for now, it helps explain why for almost every GraphQL server, if you load the GraphQL endpoint URL in a browser, you'll see this page or something like it in dark mode, which is the graphical tool. On the right, there are a couple of tabs, one of which shows the schema itself, and the other of which shows the documentation generated from the schema automatically. Next, we can move up into the upper left section and look at how you actually write an operation using GraphQL. The first thing you have to do is declare that this is, in fact, a query. That way, you're distinguishing versus a mutation or a subscription. Next, you can add parentheses to allow you to pass in a variable. The bit with the $ prefix is the actual name. The ID is the type. And again, that exclamation point is saying that this is a non-nullable type. Next, you can start making a query. Now, remember, there's a list of possible queries that's defined in the schema, and this is using one of them. The unannotated ID is the parameter name. The ID with the $ in front of it is the variable that you just declared above. And you can see from the query definition that the type returned will be a launch. So you can use the definition of the launch type to see what the properties of the launch are, and then access them through that level. Finally, you can look at the properties of the custom types like mission and rocket and use those to pull out whatever properties you want of those types. So now you've got a whole query, and you're probably wondering how to pass in the parameter that was outlined earlier. In graphical, the answer is that there's a little section below the query section where you can specify variables in a dictionary. In this case, there's a little secret, which is that ID is a type alias for a string, so you do need to pass the identifier as a string. Next, moving back out to look at all of graphical, you'll see that big old play button right in the middle. And now that you've got a written operation along with the parameter you're passing in, you can just smash that bad boy to actually run the query, and you'll see the result pop up in the right-hand panel. Now, one thing I want you to take particular note of is the shape of the response. The JSON that's returned matches the shape of the query absolutely identically, along with the names of the properties in JSON. By creating a query in a certain shape with the field names prescribed by the schema, you can know exactly what your response is going to look like. Now, I want to take a brief detour here to ask, how would a REST endpoint do this? Because this is one of the major things that drew me to GraphQL in the first place. And I want to compare the way you can do this with GraphQL to this REST endpoint from the open source RSpaceX API that allows you to get data about a specific launch. And when you call get on that endpoint, you get literally everything you could possibly ever want to know about that launch. I had to zoom GitHub way out to even be able to get a screenshot of this response JSON. And really, if you're only going to be using the mission name and the rocket name, that's way too much stuff. With REST endpoints like this, you're going to waste your user's networking allotment and battery on a whole ton of data that you are immediately going to drop on the floor. With GraphQL, you're able to get exactly the data that you need and only the data that you need. And frankly, that is a lot better for everyone. And even if you decide when you look at the response, you know what, I don't like the name of this field called site, I want it to be called something else. You can actually do that really easily by doing something called aliasing, which allows you to change the name of the field returned to you, which is pretty neat. So now that you've got a schema that defines what's possible to ask for and a query that defines what you're specifically asking for, it's time to do some validation. So are you going to tell your code that it's awesome so that it feels better about itself and it builds on the first try? No, you are not. Validation is the ability to compare your operation to your schema and find out before you even lift a finger if what you're asking for is even possible. So graphical is very nice about this, and it allows you to get an error message that tells you why something won't work immediately as you type. But what if the same thing that powered this could also validate, maybe not as you type, but could validate the GraphQL operations that are in your Xcode project? And that once all of your operations were validated, you had enough information with the types that are defined in the schema to generate all of the code necessary for doing all of this in either Swift or Kotlin, including all of the parsing code. This is where the iOS and Android SDKs for Apollo come in. Now, one thing to be aware of that's not part of the GraphQL spec, but is required for both iOS and Android code generation to work, is that this query we've been working on is called an anonymous query because it doesn't have a name. In order to generate code that works with this query, we need to give it a name. And I'm going to show you what we do with that name in a very shortened version of our generated iOS code that essentially leaves out a bunch of the messy stuff that we're doing under the hood to make all of this work right now. This is also hopefully going to be much more similar to how this will work for both iOS and Android once some ongoing work on both iOS and Android code gen is completed. So here's the nested class and structs that are being created for the operation that we've been looking at. The operation was named launch info, and it was a query. So the code gen automatically appended query to the end of it to make it clear in the class name what we're doing. The parameters name and type are both pulled from the query's declaration so that you can call this like a normal Swift class. Next, we have a nested class which holds data, called data, which holds the parsed response from the server. Now, you may be wondering why the return value here is optional. If you look at the definition of the query, you'll see that launch is unannotated, which means it's optional, which makes sense. If someone were to pass in an ID for a launch that didn't exist, you'd want the server to be able to return null for that. Anyway, that launch is of a type that's nested within launch info query and data. So why is it nested? Because it contains only the properties that were asked for in the launch info query. There are other properties on launch after all, but these are the ones that you asked for. You can't even try to access the isBooked property on this object, because even though that's a property that exists in the schema, it's not a property you got info for with this request. This helps you figure out really, really easily when you need to add new fields to your query. If you need a piece of data and it's not on the object, you need to add that field. And that's the same reason that the mission and rocket types are nested as well, to allow that level of granularity. And the best part of all of this is that you don't have to write this code. Apollo iOS and Apollo Android will generate this code for you. And that is the case for every single operation you hand us. The more stuff that you switch from a REST endpoint that you're building out all the boilerplate for, the less boilerplate that you are going to have to personally write. You also don't have to write a networking wrapper that formats everything properly to send to your GraphQL server, then parses the return values out of JSON into these generated types, because Apollo's code generation and parsing already has all of that covered for both iOS and Android. You're welcome. Now, there's not a way for me to write everything that you need. You are going to need to write some code. And this is what it's going to look like in iOS. You have an Apollo client instance that you can use to do operations. You hand it your constructed query, and then it goes out to the network and it gets you a Swift result, which you start by as you do with any Swift result, you start by switching on to see what you've got. Here, if you've got a failure, it's generally either something that happened at the URL session level with loading or some kind of parsing error. And you can handle that error however you want, probably by doing something better than just printing it out, up to you. In the success case, you actually get a GraphQL result. Now, wait, that seems a little excessive. You got a result that contains a result? Why is that? And the answer is because GraphQL allows you to return partial results when part of a query works, but another part of it didn't. So imagine in our world here that you're able to get most of the information about the launch, but for some reason, the data for the rocket couldn't be loaded. And importantly, the rocket is a nullable property. In that case, you get both an error about why the rocket couldn't be loaded. Maybe the Riker service that deals with rockets is down. And you'd also get the rest of the data that you've asked for since it was possible to get it. Now, this optional chain here leads me to a quick pro tip, which is that you can use Swift or Kotlin extensions to allow you to handle nullability gracefully from the final call point. Now, you'd have to add this outside your generated API files, which are constantly overwritten, but you can add an extension that turns a nullable property into a non-null property really easily, or moves things up to a higher level for better readability. Now, that's really getting down into the nitty-gritty of how to use these things. So I want to zoom way, way, way back out for the last few minutes of this talk, because now that you know how it works, it's probably helpful for me to outline what GraphQL is really good for. And I've already covered a big piece of this, which is that you can much more easily get the data that you want, and only the data that you want, not the data that every single application that would ever want to use a specific endpoint ever would possibly need. Another benefit of this is that adding stuff to a graph is much, much simpler than adding things to a REST API. And I've had this experience quite a bit personally. I suspect so have many of you. There's a field that is available publicly on one endpoint, but I need to access it on a different endpoint. And so I say, can we add this field that's on endpoint A to endpoint B? And the backend team says, sure, we'll put that in the backlog. And then there's some kind of emergency and the project manager prioritizes a new feature that the CEO wants. And it takes a month or two just to add a piece of data that's already available in public to a different endpoint. With GraphQL, anything that's available in the schema can be accessed by the relationships in the graph. Remember this example? The graph here only has to know that a person can have a middle name and that each of these relationships are possible. And you also have a way to tell which of these relationships are optional and which ones are not. Adding something to the schema means it's available everywhere in the graph you can traverse to it, given the relationships between the different pieces of data. So those are some pretty compelling pros. Let's talk about a few of the known cons, because GraphQL is a real sweet hammer, but not every problem is a nail. And it doesn't mean that the GraphQL community has not tried to make the problem a nail, which is definitely the case with uploading files. Because GraphQL is designed to send much smaller bits of data around, the community came together with a standard that has a specially named type that allows you to create a multi-part form request to upload a file along with a mutation that can replace variables temporarily null with those parameters with the uploaded file on the server at runtime. The problem, as with all mad science, is that while this is technically possible, it is really a stretch to say that the uploading itself should be part of the graph. And it is super, super error prone. A much better way to handle uploads in GraphQL is to continue using whatever method you've already been using, whether it's just a REST call or using something like the AWS SDK to upload to a specific bucket. And whatever you're doing should return the URL of where that uploaded file will live. Once you have that, you can send that to your graph as a string much more easily, and you will have way, way fewer problems in your life. Another thing that's not a huge advantage of GraphQL is working with highly optimized queries. This is when your backend has tuned the hell out of everything, removed every unnecessary field, shaved every millisecond off the database call that they possibly can. In that case, REST can be faster. Now, there is a lot of tooling around GraphQL, including a whole bunch made by Apollo, both free and paid, that helps you figure out where bottlenecks are in the actual requests that are being made and executed here. But while you can use that to find bottlenecks, you can't completely eliminate them and still have the kind of flexibility to allow people to request whatever they want. This is absolutely a trade-off, but it's one that's worth being aware of. Speaking of trade-offs, while adding stuff to GraphQL is way easier, it's much harder to completely remove things, because while the ability to add things to the schema and the availability of anything in the schema to anything querying it means that versioning isn't necessary, it also means that versioning isn't really meant to be done with GraphQL. So how do you remove things? Because there may be clients that are relying on the fields that are in the schema that can't be changed. You always have to start by deprecating the fields in the schema before removing them. And while both our iOS and Android SDK take that deprecation annotation from the schema and add a Swift or Kotlin warning for you when you're using a deprecated field to try and tell you to stop doing that, they can't actually force you to stop. Your server team still has to look at actual usage after something's been deprecated, wait until nobody is actually asking for that field anymore before actually saying goodbye to that field. The good news is that this is way safer for clients, but the bad news is that just removing something becomes a whole procedure. Another thing that GraphQL isn't always good for is keeping your security super simple. And you may have already guessed this because, well, when I say that if you have access to a graph, you can ask for anything on it, developers get really, really, really excited. The security team, on the other hand, tends to be really horrified. Because if you're just used to being able to slap a 401 unauthorized on any endpoint that needs to be protected, the fact that GraphQL only has one endpoint means that you are not going to be able to just return that kind of status code willy-nilly. You're going to have to think on a more field-by-field basis about who should have access to what and work with your backend team to make sure that that works well for everyone. Oh, and one pro tip, schema introspection is on by default unprotected. This means that anyone who knows the way to query a GraphQL server to return information about its schema can get your schema really easily. You probably want to make sure that there's at least some kind of API needed to get that information. So we have reached the part of the talk where I'm going to try to tell you what I told you in a way that makes you remember some of it. So first, a graph is a way of thinking about databases and how they're related. GraphQL lets you ask for information about what's in your graph and how it's connected, which is defined by the schema, along with types and the relationships between your pieces of data. You can then use operations to specifically ask for exactly the data you need and receive only that data back. And finally, remember, as with any tool, GraphQL has a lot of stuff that it can do really well. That is not literally everything. Be aware of its strengths and its weaknesses and use them wisely. Now, if you're interested in trying out either our iOS or Android SDKs, we've got tutorials available at these two URLs. And I'm going to be taking questions in the Twitch stream after this stream is done. Thank you all very much for listening to a very quick introduction to GraphQL, and I hope you enjoyed.